Okay, so let's continue for continuous random variables for cumulative distributive function. So we have already learned how to do probability density function or PDF. So now we are going to see cumulative distribution function, or we call as CDF. Okay, nama pun cumulative, it almost the same as discrete random variable, but as I said, continuous mesti ada integration involved. Okay, so as you can see, the definition here is the CDF we denote it as capital Fx. Okay, capital Fx or Px less and equals to x. Okay, which is the definition is integrate from negative infinity to x. Okay, kalau untuk probability density function we integrate from negative infinity to infinity, we get 1, but this one we have to integrate from negative infinity to x only. Okay, which is ada certain limit yang kita nak. Alright, so let's take a look at the notes here. So if x is a continuous random variable with probability density function for negative infinity to infinity, then CDF of x is given by this. So this is the definition. Okay, fx, capital F x equals to px less than equals to x, which is definition is we are going to integrate fx from negative infinity to x. Okay, let's say if you have integrate negative infinity to a fx dx, then this will be the same as fa. Okay, so now fx is in fact given by the area under the curve from negative infinity to x. So let's say if I have a graph here, this is x, this is our y, and then let's say if I have this graph here and this is your x. Okay, so we are going to integrate from negative infinity up until x. So this is y equals to fx. We are going to find the area under the curve. Okay, so px less than a, px less than equals to a. As I said, for continuous, the equal sign doesn't matter. We can just ignore the equal sign. So px less than a is the same as px less than equals to a. Unlike for discrete, equals to penting. Okay, so this means as negative, integrate from negative infinity to a function fx. Okay, so the same thing for finding probability. We can just simply ignore the equal sign here. All of this will be translated as FB minus FA. Okay, if you want to find the probability of PX between A and B, we can just simply put FB minus FA. Okay, so it's easier. If you have continuous random variable, CDF, you want to find the probability, simply FB minus FA. But if you have continuous random variable, you have PDF, you want to find the probability, you have to integrate first. Okay, alright, so let's see here. If the median is m, then we have to integrate fx from negative infinity to m, which is it will be equals to 0.5. Okay, so this is how we find the median. Or sometimes we can also, okay, if you use this formula here, you have to have the probability density function. This is your probability density function. But if you have your CDF, you can use this formula. Okay, so this is if you have PDF, this is if you have CDF. Okay, so let's do a little bit note here. If you want to change from graph PDF to CDF, okay, which is as you can see from here, we know that from PDF, from probability density function, we want to change to cumulative distribution function, we have to integrate. Okay, so how? Okay, I have the example here. We have the function of PDF, which is we have to start from x less than 0, x between 0 and a, which is here is 0 to 3, and then we have to go from x greater than a. Okay, so let's see here. Let's do one more note here. Let's say if your graph PDF is fx equals to one function, let's put that as gx hx, and this one is for x is between a and b, and this is for x is between c and d. Sorry, this is b and c. x is between b and c. This is the equal sign here. Alright, so as I said, if you have the piecewise function, what we have to do is we just simply do a number line so that it's easier for us to see the function. So we have between a and b, we have function hash x. From b to c, we have function gx. This one is obviously 0, 0. Okay, first we are going to start from negative infinity up until a. Okay, so that means for the range is for x less than a. Okay, so we want to find the CDF, which is capital F, fx equals to, which is supposedly we are going to integrate from negative infinity to a. But for CDF, we always end up with x. Okay, the last limit here is supposed to be x. So this one, just replace with x. Okay, because the definition said so. It is from negative infinity to x. Okay, so now for the limit x less than a, the function is 0. So here we simply get equals to 0. Okay, now we are going to continue. So this is this part here. Okay, now we are going to continue for this part, which is for x is between a and b. If you don't know how to put the equal sign, just follow the question here. Okay, so this is the equal sign. So this is the yellow part is for this part here. Okay, now we are going to find the function, which is capital F x, start from negative infinity to a to b. Okay, which is supposed to be like that. Okay, let's just put negative infinity to a, function 0 dx plus a to b, which is we have function hx dx. But remember, I said the last limit has to be x. So this one, we just get rid of that and replace with x, because we want function. If you put the value, if you put the limit b, you are not going to get a function, you are going to get a value. Okay, we want to find a function, so the last limit here is supposed to be x. Okay, and also this part is actually the same thing as before, which is fa. Okay, the value from previous limit that we have done here, which is this is fa. So this is simply 0 equals to 0. So this will be just fa only. So this will be fa plus integrate 0x hx dx. Okay, so now let's continue for the next limit, which is we have for b, x is between b and c. Okay, so for this part here is the same as this part here. Okay, again we are still going to integrate from negative infinity. Now we just follow the limit, negative infinity to a, which is function 0, and next is a to b, which is function hx, and the next one is plus b to c, function gx. But remember, the last limit always has to be x. Okay, so replace this with x because we want a function. Okay, so this one is also the first two integral here is the same as fb. Okay, which is ends with limit b, so the same as fb, which is this is actually your fb. Okay, the answer from previous integral is fb. So here we will have equals to fb plus integrate b x gx dx. Okay, now the last one is, let's just me quickly resize this. Okay, last one is for x greater than c, greater and equals than c. Okay, which is this part here is the same as this one here. which is we have fx. If we do the integral, it's going to start from negative infinity to a function 0 plus a to b function hx plus b to c function gx, and the last one is c to infinity, but we change infinity to x, which is also function 0, which is this thing is the same as the first three of the integral is the same as fc, okay, which is the answer from the previous integral here. So this will be the same as fc, which is the final answer has to be equals to 1, because remember your cumulative is equals to 1, okay, everything, if you plus everything together you get equals to 1, okay. So maybe a little bit confused sebab kita just guna unknown variables. So now we are going to see the example 18. X is a continuous random variable as before. Always check, identify what's the question give to us. Okay, the question give continuous random variable. So always something about integration in that question. Integration or differentiation depends on the next thing, which is it gives us probability density function. Okay, continuous PDF. So we want to change to CDF. Okay, the first question asks us to change to CDF. So there's always integration involved here. So as before, let's see. We have the range from 0 to 4, which is function fx. 1 over 8x is for x between 0 and 4. So the first question asks us to find the cumulative distribution function. Okay, so now question A. What we have to do is we have to take from negative infinity to 0 first. Okay, so negative infinity, which is that is for x. Let me just quickly put this for x less than 0. Okay, which is this part here, which is function is 0 here. So we are going to integrate fx is equals to integrate negative infinity to 0, but remember the last limit has to be x. Okay, function is 0, so this one will simply be 0. Okay, so the next one, next limit is for x is between 0 and 4. Okay, which is we have the function 1 over 8x here. So now we have fx equals to, start from the early, the negative infinity, which is negative infinity to 0, function 0, plus, which is supposedly 0 to 4, but remember the last limit has to be x, so we replace this with x. So your function here is 1 over 8x, 1 over 8x dx. Okay, which is this thing is the same as I said in the note here, the first one is your FA. Okay, so what we have to do here is, this is actually our FA plus, so this one we have to integrate as usual, x squared over 2, integrate from 0 to x. So FA, this thing here is from the previous function. Okay, where we have to get this, we get to from the previous function. This is actually your FA. So FA equals to 0 plus 1 over 8. So we sub x into x, that will be x obviously, x squared over 2. Okay, we sub 0 minus 0. And the last one is we are going to get function 1 over x, x squared over 2, so that will be 1 over 16 x squared. So that is your fx for x between 0 and 4. And the last one, the last range here is for x greater than 4. Okay, so we have for x greater than 4, which is, let's start from the start here, which is fx equals to negative infinity to 0 function 0 plus 0 to 4, which is function 1 over 8x plus 4 to infinity, which is supposedly infinity, but we have to change this into x. Okay, the last limit has to be x, which is function is 0. And this 2 is actually equals to fb, which is b here is 4. Okay, this is your fa. Fa is f0 lah. Okay, fa is 0. So this is actually your a. This is your a. This is your b. So this is fa. This is fb. Okay, both of these represent your fb. Which is f4. Nampak limit dia yang terakhir ialah 4. So this will be f4. So plus dengan that one will be 0. So where we are going to get f4 dekat sini? So f4 is from the previous function 1 over 16 x square. We substitute 4 dekat situ. So that will be 1 over 16 4 square, and that will be 16 divided by 16, we'll get 1. Okay, then you know your function is correct. The last answer here has to be 1. Okay, kalau tak confident buat macam ni, you can always integrate this one as usual. Okay, and don't forget, this is not only the function. The question asks to find the cumulative distribution function, so you have to give the last final answer as the function, which is as the piecewise function fx equals to, okay, which is we have 0, 1 over 16x square, 1, 0, 1 over 16x square, and 1. Just quickly write it one more time. 0, 1 over 16x square, and 1. And the limit, you just follow what you have written in the red color. So this one is for x less than 0. This one is for x between 0 and 4. And this one is for x greater than 4. And this is your cumulative distribution function. Okay. So let's see question B. Ask us to sketch graph fx. Okay, so graph CDF. So what we have to do is simply just sketch the graph lah. Kita ada x. This one is actually your fx, and we write the function, which is here we have 1. Okay, because we only have 1, and we have 0 to 4. So for x less than 0, your fx is equals to 0. So that will be 0 here. Okay, kita tebalkan sikit. So this is x less than 0. Okay, and then for x between 0 and 4, the function is 1 over 16x square, which is that is quadratic. So almost like this. Okay, stop at 4. Because for x greater than 4, it will be equals to 1, which is linear dekat situ. So this is empty circle, linear dekat sini. Okay, so that's going to be your graph. Simply just piecewise function sebenarnya, piecewise graph. And the last one, calculate px, probability of x between 2 and 3. Probability of x between 2 and 3. You already have the CDF here. Okay, as I said, if you don't have the CDF, you only have your PDF, you want to solve probability, you have to do integration obviously from 2 to 3. Okay, what function here? 1 over 8x. But you already have the function for cumulative dekat sini. So this one will automatically translate as f3 minus f2. Okay, fb minus fa. So 3 dekat sini, both of these 2 and 3 is on this function here, so we just substitute 3 square over 16 minus 2 square over 16. Okay, and we get the final answer 5 over 16. Okay, so that is how we change from PDF to CDF. Okay, so let's try one more question here, which is we have another 2 function for piecewise function kita. So again, we have continuous random variable, which is given to us PDF. There's always integration involved in this question. Okay, sebab PDF nak tukar CDF mesti ada integration. So the first question asks us to obtain the cumulative distribution function. So let's write the number line first. We have negative 2, 0, 2, which is this one is 3 over 16 x plus 2 square. This is 3 over 16 x minus 2 square. This will be 0, this will be 0. Okay, now, so always start with 4x less than 0, which is x less negative infinity to x. So here we want to find function fx, capital Fx, which is cumulative. So integrate from negative infinity, which is supposedly 0, but the last limit has to be x, because we want to find the function. This one we get 0. Okay, sorry, this one is not 0, this one is negative 2, x less than negative 2. Okay, which is this part here. Okay, and then the next one, let's continue. For x is between negative 2 and 0. Okay, if you don't know where to put your equal sign, just follow the question. Just equal is here. So we have fx equals to, from the start, negative infinity to negative 2, function 0, plus negative 2 to 0, supposedly, but the last limit has to be x because we want a function. So the function that we have here is 3 over 16 x plus 2 squared dx. Okay, so this one here is f0. Okay, sorry, f negative 2. Okay, if you know that, this is your a, this is your a, b, c. Okay, so this will be equals to f negative 2 plus, so this one we have to integrate 3 over 16. And now for x plus 2 square, we can use the power rule, which will be x plus 2 cube over 3 from negative 2 to x. Where are we going to get f negative 2? So this is your f negative 2, okay? Which is the answer is 0. Always look at the previous range yang kita dah buat. So 0 plus 3 over 16 multiplied by 3 kat situ, or we can just simply put 3 over 16. So dekat sini substitute x into x, akan dapat x lah. So we'll have x plus 2 cube over 3, and we substitute negative 2 into here, we'll get 0 minus 0. Okay, and then we cancel out 3 here. We'll have the final answer here is x plus 2 cube over 16. So that is for our f0. Okay, the same thing as f0. Now let's continue to the next range. So kita tahu ini is the same as this one here. So the next range is for x is between 0 and 2. Okay, we have our fx, start from the negative infinity to negative 2, function 0, plus negative 2 to 0, function 3 over 16 x plus 2 squared dx, plus 0 to 2, function 3 over 16 x minus 2 squared dx. But remember, the last limit has to be x. Because if you put negative 2, you'll get a constant. Okay, you get the value, a value. We don't want a value, we want a function. So you have to replace your last limit with x. Okay, so both of this, the first two integrals is the same as f2. Sorry, f0. Okay, so this is your f0. So both of this is equals to f0. Okay, which is FB lah, dia akan follow. Dekat sini ialah FA, dekat sini ialah FB, the next one ialah FC. Okay, this one is F negative 2. So this 2 here is F0. Okay, and then we only have to integrate this part lah, 3/16. Just we have x minus 2 power 3/3 integrate from 0 to x. If you don't want to use this part here, it's okay. You can just integrate like usual for this one. Okay, but it takes time lah. Instead, you can just substitute your F0. Okay, where are we going to get the F0 is from the previous integral. What do we have here? Okay, so we have x plus 2 cube over 16. So we substitute 0 here. 0 plus 2 cube over 16. So here we can cancel out 16. So we have we cancel out 3. Substitute x minus 2 cube. Substitute 0, we'll get minus negative 2 cube. And finally, the answer is, here is 8/16, we have 1/2. Plus x minus 2 cube over 16. And the last one is 8/16, we'll have plus 1/2. And here we have x minus 2 cube over 16 plus 1. And that will be our F2. Okay. Haven't finished yet. Still got one more range here, which is for last one is x greater than 2. For x greater than 2, we simply just put everything. Fx equals to negative infinity. Dekat sini ada markah sebab tu saya tulis negative 2 0 dx. You just follow your number line dekat tadi. 0 3/16 x plus 2 squared dx plus 0 to 2 3/16 x minus 2 squared dx, and the last one, which is supposedly 2 to infinity, but we have to change this into x. And the whole thing here is F2. Okay, plus 0. So where are we going to get the F2 is from the previous function here. Okay, if we just simply put 2 minus 2 cube over 16 plus 1, and we'll finally get the answer equals to 1. So you know that your answer is correct there. Okay, so make sure, remember to write the function. Okay, so your function is supposed to be like fx equals to piecewise function. So just put everything that we have. We have 0, and then we have x plus 2 cube over 16, and then we have x minus 2 cube over 16 plus 1, and the last one is our cumulative. Total cumulative is 1. Okay, and then the range, you just follow what you have already written in your function. So here is for x less than negative 2. Here is negative 2x 0. Here is 0x2. And this one is for x greater than 2. So that is our cumulative distribution function. Okay, so sketch graph of x of f and f. This one you can do it by yourself. And the last one here is find px greater than 1. Question C. Px greater than 1. You have your cumulative, so but remember your cumulative, it has to be less than. Okay, cumulative has to be less than. So what are we going to do is we have to change this one here to 1 minus px less and equals to 1. Okay, the definition, if you want to use fx, you have to change this into less and equal. So we have learned in this grade, kat sini total probability ialah 1 tolak dengan x less and equals to 1. So this one, the definition is the same as 1 minus f1. Okay, so check where is your x equals to 1 in which range, which is in this one here, so we can substitute 1 into that function. 16 plus 1. Okay, so we'll get the final answer 33 over 16. Okay. Okay, so let's see one more example for continuous random variable with probability density function. So that's the two things that you have to identify: probability density function, continuous random variable. So there's always integration involved in this question. So first, the question said find fx, which is this is actually your CDF. Okay, so first we have a piecewise function with 1, 2, 3 function, a lot function there. So just put your number line. We have 2, 3, 5, 6. Okay, for x less than 2, function is 0. For x between 2 and 3, function x over 3 minus 2 over 3. For 3 to 5, we have function 1 over 3. And last one here is 2 minus 1 over 3x, and this one is 0. Okay, now we have to do for each and every one of this range here. Okay, so there's going to be 1, 2, 3, 4, 5, 6 ranges here. So let's get started. Here the first one is for x less than 2. Okay, for x less than 2. So this is going to be your A, B, C, D. Okay, and this we are going to do for FA actually. So first one, we want to find fx equals to integrate from negative infinity to 2, which is the function is 0 equals to 0. But remember, this one we have to replace with x. Okay, but this one doesn't matter, it doesn't affect, but it has to be x as the limit. Okay, so the next range is from 2 to 3. Okay, for x, for x between 2 and 3. Okay, so for the equal sign, just follow the question here. So we have equal at 2 here. Okay, now we want to find fx. So we have negative infinity to 2, function 0 plus 2 to 3, but this one we have to replace with x. Okay, the last limit has always be x. Okay, which is this one, the function is x over 3 minus 2 over 3. X over 3 minus 2 over 3 dx. So this is actually your f2. Okay, so we have f2 plus, so integrate this one here, we have integrate x over 3, we have x squared over 6 minus 2 over 3x from 2 to x. Okay, so this one is actually this one, which is actually this one here. Okay, so here we'll have 0 plus, substitute x into x squared, you'll get x squared over 6 minus 2 over 3x. So that is one thing. Minus, substitute 2 into this, we have 4 over 6 minus 4 over 3, we'll get 2 over 3 there. Okay, and we'll have the final function here is x squared over 6 minus 2 over 3x minus 2 over 3. Okay, which is the same as f3. Okay, so that is going to be your f3 actually. Okay, so next one, let's go to the next range, which is between 3 to 5, which is with the function of 1 over 3. For x is between 3 to 5, so we have fx, just follow from the negative infinity to 2, function 0. Okay, here we have negative infinity to 2, and then 2 to 3, and then 3 to x. Okay, function 0, and then we have 2 to 3, which is the function is x over 3 minus 2 over 3 dx. And the last one is supposed to be 3 to 5, but this one changed to x, which is the function is 1 over 3. Okay, And this one here, the first two integral is actually equals to f3, which is the same as this one here. What we have to do is we just substitute 3 into the previous range, the previous function. Okay, so this one we have f3, so we only have to integrate this part. Okay, which is we have 1 over 3 x, integrate from 3 to x. So this one, the yellow color, just substitute into the previous function, which is we have x squared over 6, so that's going to be 3 squared over 6 minus 2 over 3 times 3 minus 2 over 3. And this one here we have 1 over 3, substitute x, substitute 3, 9, that will be 3 over 3, so that will be 1. Okay, so put everything in your calculator, you should get 1 over 3x minus 5 over 6, which is, this is your f5. Okay, f5. So actually this one will be your fa, this is actually your f2, this is actually your f3, this is actually your f5, and the last one is f6 lah. Okay, dia akan follow a, b, c macam tu. Right, so let's go to the last range here. We have, not last, second last range. We have for x is between 5 and 6. So we have fx equals to from negative infinity to 2, 0 dx plus 2 to 3 function x over 3 minus 2 over 3 dx plus 3 to 5 function 1 over 3 dx, and the last one is 5 over 5 to 6, or we replace your 6 with x, and the function is 2 minus 1 over 3x dx. Okay, and the whole thing here, the first 3 integral is actually the same as f5. Okay, same as f5 and same as this one here. So what we have to do is just substitute 5 into the previous function, and we only have to integrate this part here. So we have 2x minus x squared over 6, integrate from 5 to x. Okay, now substitute the 5 into 1 over 3, multiply by 5 minus 5 over 6 plus, so substitute x into 2x, we get 2x minus x squared over 6, and substitute 5 into here, you should get 2 times 5 minus 5 squared over 6. And put everything in your calculator, we should end up with 2x minus x squared over 6, and lastly we should have minus 5. Okay, so that is your function for f6. Okay, so this is actually going to be your f6. Okay, now the last range is for x greater than 6. Okay, so just start from the beginning. We have fx equals to negative infinity to 2 function 0 plus 2 to 3 function x over 3 minus 2 over 3. You have to write everything, okay, not leaving one thing. 1 over 3 dx plus 5 to 6 function 2 minus 1 over 3 x, and the last one is 6 to infinity, and we replace this with x, 0 dx. And the whole thing here, the whole thing 1, 2, 3, 4, the first 4 integral is actually the same thing as f6, which is we get from the previous function. So here plus 0, so just substitute 6 into the previous function. We have 6 squared over 6 minus 5, so you should get equals to 1. Okay, and that's our cumulative distribution function. Don't forget to write it as the function. Equals to piecewise function. Okay, just put everything that we have, which is the first one, we have 0. We have 0. Second function, we have this one here. So x squared over 6 minus 2 over 3x minus 2 over 3. The third function, we have this one here, 1 over 3x minus 5 over 6. The fourth function, we have this one here, 2x minus x squared over 6 minus 5. And the last one, we have 1. Okay, it has to be 1. And then we just put the range. So this one is for x greater than 6. Just follow what you have written here. And this one is for 5x6. This one is for x between 3 and 5. This one is for x between 2 and 3. And the last one is for x less than 2. So that is your cumulative distribution function. Okay. Alright. So next thing is we want to find probability of x between 2 and 3 over 5. You already have your cumulative distribution function. So what we have to do here is actually just, we want to find, this is question B. We want to find x is between 2 and 3.5. Since we already have the CDF, we can just simply put f 3.5 minus f2. If you don't have the CDF, you have to integrate your PDF. Okay, so 3.5, where does 3.5? So this one here. So we have to substitute 3.5 into this function here. So we have 1 over 3, 3.5 minus 5 over 6. And 2 we have it here. The equal sign is here. So substitute here, we'll get 2 squared over 6 minus 2 over 3, 2 minus 2 over 3. And we'll get the final answer, which is equals to 1 over 3. Okay, and we have one more question here, which is px greater and equals 5.5. Remember, I said if the inequality is greater, you have to put 1 minus. Okay, because for cumulative, it always less than. Okay, so we want to find px greater and equals to 5.5. Since it is greater, we have to do 1 minus px less than 5.5. Okay, so less than equal 5.5. So that simply means f 5.5. So where is your 5.5? Which function? This is 5.5. So this function, we just substitute into that function. 1 minus, we have 2 times 5.5 minus 5.5 squared over 6 minus 5. We'll get the final answer, 1 over 24. Okay, so that is how we change from PDF to CDF. One more time, we recap. PDF to CDF. PDF is small letter f. So CDF is big letter F, which is, it will be like this here. This thing here. Okay, so how are we going to change PDF to CDF? We basically just integrate every function according to the range. Okay, so that's it. I'll see you guys in the next video.